Hi, today we're going to talk about Earth's ideal energy budget. So, in ideal conditions, what is that relationship between energy emitted and absorbed by Earth systems? When I talk about Earth systems, I'm talking about things like the atmosphere and the lithosphere, where processes are happening in Earth or around it. Let's start with Earth. Now, Earth has a lot of different features on land, like vegetation, water, glaciers, and mountains. We also have features just beyond that crust, like the troposphere, which is where weather happens and clouds form. All of these are important when we're looking at energy flow. Energy is going to enter Earth systems primarily from the sun as solar radiation. This accounts for 341 units of energy entering our systems. Solar radiation can be absorbed by the atmosphere and absorbed by the surface. When we talk about the surface, we mean not only the crust, but also the air just above the crust in that very lowest level of our troposphere. Solar radiation can also be reflected by clouds and the atmosphere. It can also be reflected by the surface. This is especially true at features like glaciers, large snowfields, and large bodies of water. Of the 341 units of energy that enter Earth as solar radiation, 102 of those units are reflected back out to space and don't actually become transformed or transferred within Earth systems. So if 341 units of solar radiation enter Earth systems and 102 units of that solar radiation are reflected out to space, how much solar energy is absorbed by Earth systems? To find our answer, we're going to take our total amount of solar radiation and subtract the amount that's reflected. So we have 341 units minus 102 units, we get an answer of 239 units of energy that are being absorbed by Earth's atmosphere or surface. Right. Now that we have that energy entering our systems, things are going to happen at the surface. That solar radiation is transformed into thermal energy in water. When this happens, we get a process called evapotranspiration. What this huge word means is that water in places like oceans, lakes, and streams, or water that's released during photosynthesis, becomes vapor in the air and it rises in the atmosphere. When this happens, thermal energy is also released and rises where it's absorbed by the atmosphere. Another interesting thing that occurs is the development of thermals. So solar radiation heats our atmosphere unevenly. We'll get pockets of hot air that we call thermals, and those pockets are going to rise. As they rise, they transfer thermal energy that's absorbed by our atmosphere. Those pockets of air then cool and sink. So we have movement of air and energy through convection, the same way we have movement of magma and thermal energy from convection in our mantle. So evapotranspiration and thermals are one example of thermal energy being moved and absorbed by our atmosphere, but a big movement of energy in Earth systems is in the form of infrared radiation that's released at Earth's surface. The solar radiation coming in from the sun is going to be transformed into thermal energy. Objects with thermal energy also release infrared radiation. That infrared radiation can be emitted directly to space. It can also be absorbed by our atmosphere. So, true or false? Earth emits infrared energy during volcanic eruptions. What do you think? So this is true. Earth will emit thermal energy as well as infrared energy, and that energy can be seen from space using satellite telescopes. The picture below is of the infrared radiation being released during the eruption of Kilauea in Hawaii back in 2018. So while volcanoes can contribute to this emission of infrared radiation, a good portion of this infrared radiation enters Earth systems as solar radiation. By now, you've probably noticed there's a lot of energy being absorbed by our atmosphere. The atmosphere doesn't want to contain that energy. So what happens is it will release some of that energy as infrared radiation that will eventually move out of Earth systems into space. Another key thing that happens is that this release of infrared radiation is not only absorbed or emitted, but also it's reflected back down to Earth's surface where it will be absorbed. This reflection is due to greenhouse gases in our atmosphere. That includes carbon dioxide and methane gas. This is important because if this radiation wasn't reflected back to Earth's surface, it would be emitted to space or absorbed by our atmosphere. And we would be losing more energy than we are gaining from solar radiation. So this reflection of radiation back to the surface actually keeps Earth's surface at a more comfortable temperature for life to happen. What's important to note is that this is ideal when the level of greenhouse gases in the atmosphere are ideal. If we have an imbalance in the amount of energy being reflected and emitted, we'll have a change in conditions on Earth's surface, and we could see a change in life as well. So what do you notice when you compare the values for the amount of solar radiation entering Earth, which was 341 units, the amount of solar radiation that gets reflected back to space, which was 102 units, and the amount of infrared radiation that's emitted to space, that's 239 units. Hopefully you notice that the amount of energy entering Earth's system is the same as the amount of energy exiting Earth's system. Again, this is under ideal conditions. Let's summarize what we discussed today. First, energy enters Earth's systems as solar radiation from the sun. Energy exits Earth's systems as reflected solar radiation and emitted infrared radiation. And if we want a balanced energy budget, the amount of energy entering Earth systems must be equal to the amount of energy exiting Earth systems. If you have any questions, please feel free to watch this video again and reach out to your teacher for more help.